simplify fully this algebraic fraction. Now, once upon a time, you probably would have simplified something like x squared over 5x. Or maybe it would have looked a bit like 3a squared b over 6ab squared. Actually, I'm going to show you how you do both of these. The one on the right, you can actually just cancel out x's. You just get x over 5. The one here is a little bit more involved. So you can cancel out those. You can cancel that b out with that one. And the 3 over 6 becomes 2. So you would get a over 2b. But my point is that actually this one over here is essentially the same as this. I've just replaced a minus 3 by x on the right. So my answer, I can just cancel this out. My answer is just going to be a minus 3 over 5. You do not want to start expanding this. That would be horrendous. No, if it wasn't expanded, your aim would be to actually factorize it. Since it is factorized, we just got a common factor of a minus 3 in the top and the bottom. We cancel out, there's just an extra a minus 3 which we leave in the top. That's our answer. Next up, factorizing this. Okay, this is going to be double brackets. There's no common factor or anything. And it's going to have to be 3k and k. One of them is going to have to be a plus and one is going to have to be a minus to get the minus 4. But just remember the 11k is what makes this tricky, because this 11k, like normally when you don't have a 3 here, you just learn that you're timesing the numbers to give this and adding to give this, but it's more complex now because this 3 has, like, it's 3 times that, and then whatever is here times k. So it's more involved. So we just try numbers out really. And you could try 2 and 2. This is what I would say to do. Just try factors. Don't worry about whether one's plus or minus at the moment. I normally, to be honest, write it a bit below, because then you can sort of say I can do 3k times 2, 6k, and 2 times k, 2. There's no way we could get 11 from that. So abandoned. Then 1 and 4. Now, if I put a 1 here, it just won't be big enough. So we'll put a 4 here. This actually ends up being right, so I'm going to put it in the right place now. So I get now, I'll put it down here actually. So I get 12k. This is when I'm doing 3k times the 4 that's there, and then k. So if we make it this one minus k, i.e. put a minus here and a plus here, it will work out. And that is our answer. Now, if you're struggling with factorizing, and I know lots of people do, then just keep at it. Just, you know, practice and build your brackets up in the same sort of way I have. We know we have to have a 3k and a k, and then you're just trying out different factors, almost just trial and error to some extent. But there are like quick ways you can realize it over time. But don't worry too much about that, especially for ones like this where there's not that many options. You will continue to improve, I'd say. Now, there is one other way that you can do it, and I'm going to show you, and that is you need the ClassWiz calculator. So they have upgraded this, but I still use this sort of older version, and you can see the name here. Hopefully it will still be relevant when you're watching this video. So you can go to Menu, and then Equation Function, Polynomial, Degree 2. This actually takes us to a quadratic. We're in fact solving the quadratic here directly. 3, 11, minus 4, and it will give us the roots. 1 over 3 and minus 4. Now, we weren't asked to find the roots, but that's what you would have got if you'd set this equal to 0. You would have got 1 over 3 and minus 4. So how to get back to the quadratic? Well, to go from the brackets to the roots, we take minuses. So we kind of take minuses again to get back to the brackets. The only problem here is that we lose the 3, because actually as you divide all your terms in a quadratic through by any number or times by any number, you'll get the same roots. It won't change it. So that's actually what's happened here. It's just divided the whole quadratic through by 3. But to get back to our quadratic, we would then times by 3. And in fact, we could then just times this bracket through by 3 to get rid of the fraction, and that would get us back to 3x minus 1 times x plus 4, or sorry, k plus 4. But sorry, I don't know why I've used x here, but it's just a little bit away from it to explain how you would get it. And you could do that with anything. You know, you could come up with so let me do one more example. So let's say you had 5x squared, this is one I've made earlier, plus 7x minus 6. And we're asked to factorize it. Same approach, go to equation function, 5, 7, minus 6. We get 3 over 5 and minus 2. So that would mean I would do x minus 3 over 5 and x plus 2. But I know I need to times 3 by 5 to get the 5x squared. And I would times the first bracket by that, 5x minus 3. So now they're all whole numbers. And again, I've factorized it. No one knows that I've sneakily used this class for his calculator. Maybe don't show that line. Just go straight there and we're good. Lastly, we're asked to simplify this. Okay, this is going to be this is going to be much harder than A. It's different from B. Okay, now remember, dividing fractions, we keep change flip. If you're dividing by this, it's the same as timesing by x over 3 over x plus 2. So that's going to be my step one. I'm not going to do too much in one go. Keep change flip. I won't go into the proof of that here, but you might want to look into it. Right. Now, one really important thing is you don't just start crossing x's out. That is absolute nonsense. You can only cancel things out in fractions when there's like common factors, which is what you're doing. When you have, say, 3 over 6 and you cancel it down to 1 over 2, it's because you sort of have 3 times 1 and 3 times 2. That's why you can just get rid of these and write 1 over 2. We just don't normally show that step, but we're going to have to show that step here. So it's all about factorizing. Then we can cancel things out. 4 minus x squared. This is a difference of two squares. We can factorize it into double brackets. It's actually 2 plus x times 2 minus x. And then I'm dividing, and I'm going to factorize the x out, x plus 3. And then I'm timesing by x plus 3 over x plus 2. Now you could bring it all together, but I'm hoping that you're happy that I can start cancelling things out like this, because I'm basically timesing by x plus 3 and I'm dividing by x plus 3. I just haven't written it over the whole thing, and I could. That's the point. When you times by a fraction, you just times the tops times the bottom. So if you prefer, let me do that. The x plus 2 cancels with the 2 plus x. They're the same as well. Just rewritten, like just slightly different order for the first one. And that gives us our answer, 2 minus x over x. So again, this just comes with practice, but be really careful cancelling down algebraic fractions. You just cancel out common factors. Well done.